Hello, everybody. Welcome to this meeting, Hyperconnected Tools for Distance Learning. Our workshop speaker is Santi Fuentemilla from Fab Lab Barcelona and Eduardo Chamorro. Welcome, Santi.
Can you hear me? Can you hear us? Well? Perfect. So, yeah, my name is Santi. I'm the one that is doing this. And I'm here with Eduardo. He's here next to me. This is why, sorry.
Safe distance.
Yeah, we have to basically wear the mask because we are in the lab. And we are in Spain also. So we have some safety regulations. And I also wanted to introduce Xavi, that is there also, that is part of the team, and also Oscar, that it should be there also, and Joseph will be also with us, but I don't know where he is now. So we are part of the Tutor Learning unit. That is, I will explain now in a second. Okay. Whatever. Do you want to start?
Go on.
Okay. So I will share the presentation and also I will share my screen. So first we will do a little bit of introduction of what we will present today. So the idea, let me do what I said that I will do. That is basically put in the chat the presentation if someone wanted to open it and follow it in your computer. And also I will try to, let's see if I can do it. Okay. Second. So, share screen. Okay. Does everybody see the screen? Yeah. Yeah. Can we see the screen? Hello?
Yeah, we see it.
Yeah. Okay, so mentioning this is part of the team that make possible what we will introduce today. So we are the Tutor Learning unit that is basically an
Change the permission, Santi, they can see the.
Okay, well, can you give it
do
them? Yeah. So this is the action research group inside the Fab Lab Barcelona that basically we take care to accompany people with the necessary methodologies and resources and technology for developing skills and competences for a certain future to become a digital social innovation. I know that is a kind of like long description, but at the end, what we are trying to do is to using the technology and the digital fabrication, empower people to have like more tools to respond, let's say, to the society problems. What we will introduce today, and I will not say anything that you don't know, is because at some point of this year, so we have this situation that probably most of you know, and this is why today we are in the same situation. So we have to start like having a lot of like online sessions with our students, and not just students, also people of the different educational programs that we are running at the home. Because just a little bit to frame what this unit and also IAC and Fab Lab is running. So this is a little bit of overall projects that happens at homes, let's say. And at certain points, so we have to basically give an answer to all of the learning experience, the academies, the masters, the residencies, and the research projects that was happening during the year, and they are actually based in a maker like methodology and also with the Fab Lab tools, and we have to find a way to basically bring the experience to be in the lab as close as we can to the home. Why? Because what we are looking for is to build these skills and competence related to the digital publication, to engage a community around certain topics that the different like educational programs was running. And these more or less is the different strategies and tools that we tested this year I will not be pretentious and I will say like create it as they was working. It was like also a try and error for us, but we want to show with you what we test and some of the tools that we create and we develop to give answers to the problems. And that problems, you know, it's like how do you engage a community, or how do you create the best learning environment to teach or to learn this digital fabrication and technology from home and in online environment. And this is why here you see basically the different tools. And maybe I will start for the ones that we will not go in deep today, and then we can follow with the ones that we will explain. So first, so we design um, an environmental and a virtual tours and 360 for actually explain a little bit what is the Fab Lab and what kind of space it has the Fab Lab.
Basically, we found ourselves after 2 months of confinement, like the mood of everybody, staff, students, was going down, really downhill. And it's a fact that, especially with Fabacademy, that is something that actually makes everything take off, and the involvement of the students. We found ourselves that yes, it's digital fabrication and there's a lot of prototyping and you can learn a lot digitally, but there's a moment that you cannot avoid to have the hands-on and the community involved into that point. Actually, I always state that the best of our academy is actually having a lot of people working together, each one doing their own projects related on the field, but completely different approaches. And you actually learn way more from the people than actually from the staff, that is ourselves, or from tutorials or whatever. Like it's the community that makes everything alive. So luckily, for example, we made Fab Lab Tour 360. So for the ones that were really missing the building, the stuff, and the things that were like all the trash and the things stacked on piled box, they could go again inside the building and remember the good moments. I just copied in the chat the link that we did with an open source tool that is Marcipano, that actually is super easy and you can even do it with your phone. Of course, with a 360 camera works better, but still works quite well. That is just for the experience in the space that the people were not being able to use for those 2-3 months. We also find ourselves like, yes, you can learn about both of the machines, but if you cannot touch the machines, it's kind of not useless, but it's not the same feeling. Like a lot of people that comes to these spaces, they are hands-on people and they want to get that type. And that were like, for example, the SPML project or the Arduino and the Arduino and Arduino still comes more electronic related. The CNC by the Sea, that is actually how to control remote machines from home, actually machines that were in the space through webcams. Also the multi-networking, so actually each student could publish data from the sensors they have at home through the computer or ESP board, like Wi-Fi enabled boards. So actually they can share, and between all the class, they could share all the sensors, activate other people's outputs. So for example, let's say Gustavo has a humidity sensor of Brazil, and Adrian is moving the servo based on Gustavo's data. That was a multi-networking. And also to make it a little bit funnier, more like a YouTube channel, we make the Making Hyperconnected, where we actually make a live session on how to do molding and casting with homeware stuff, like mostly cooking stuff that like silicone is easy to get, but when everything is closed, the only thing you have is like cookies, oil, and this kind of thing. So actually we found out and tried to make recipes like the non-technology to make technology with that to the people and have the same experience with not the same materials.
Yeah, actually, this reflection, it was very important for us to understand that we can like teach and engage the community around the program with the materials that they have at home. So this is why we like did this hyper-connected making from home, based on, for example, things that you can have in the kitchen, and you can create like molding and casting. Of course, you have to skip some digital fabrication parts, but at least understand the basics concepts of some of the digital fabrication processes. You can do it. And also for the multi-networking, this idea of working all together as the same as it happens in a lab and learning by peer-to-peer is one of the things that we wanted to reflect in this exercise. Oscar, you are there. I don't know if you want to explain a little bit more about multi-networking, how it was working for the ones that or what is behind, let's say, the infrastructure that is behind, for the ones that wanted to replicate one of that.
Yeah, can you hear me properly?
I can hear you
Very low.
very low, and I don't know if it's me or everybody's listening to you.
No, wait. Microphone.
Maybe better now?
Yeah, much better.
I have to say that
Okay.
the ones that
So,
wait a moment, Oscar. The ones that have access to the presentation, in the images we put links to the repos. If you're gonna go to the repos where we put all the documentation.
Hi, hello, Santi.
Yeah.
How are you?
Very good. Very good.
So it's very good. I also would like to tell you that this session was selected to be transmitted live on Facebook, and we have already posted you. So it's good to, yeah.
Very good. So thanks to tell us in advance. It's okay. It's okay. Okay, we are glad to share with everybody what we do.
Now
So,
in these times of coronavirus, everybody is a YouTuber.
okay, so maybe we can put the link to the presentation also in YouTube. Anastasia.
I will do that.
Okay. Okay.
So go on, Oscar. I just put the chat to the project in the.
okay. Well, so the idea, well, as Santi explained before, is that at some point during the lockdown in Spain, we were busy jumping between meetings, and we decided to do like a joint class with the students in which they weren't just listening, but also participating and doing like a more like a multi-net, a workshop in which they can actively participate and feel a little bit more engaged. So the idea of the networking session, if you go to the remote folder there in the repository, you can, what was to set up a server in a Raspberry Pi, a very accessible computer that we all know, and have it at home with instructions to replicate all in this repository to connect it to the internet in a safe way, and that the students could connect to it, send data to it. How to send data? Well, it used an MQTT broker, which is a server that is designed to ingest data from sensors and different devices and send it to other clients, like other computers or people that, or devices that we call subscribers. And basically then make a dashboard, a Node-RED dashboard that is as well a very well-known tool by IBM, very simple to use, that has a little bit of a graphic interface to make nice dashboards to let's say depict the data and show how the interactions are happening, and then show the students how their data was being transmitted from their homes to this little dashboard, and that was being published live as well, not only on a website that they could see, but also on the conference that they would do as well. During the session, what we try to do is not that the students only send data to the dashboard itself, but also that they retrieve data from it, and they could take, they could subscribe to a message, and that data from another student could trigger something at their homes. For example, imagine that you, as Santi said, or Eduardo said before, that you are in Brazil and that you want to trigger someone else's fan or light in their bedroom. You could do so by connecting one temperature sensor send it to the Node-RED dashboard, and on the other end, the client subscribing to that value, and with their Arduino doing this kind of interaction. So this encourages a little bit how the students could like get familiar with networks, as well how to get familiar with sensors and actuators, and also see that these type of things that are a little bit sometimes more far-fetched than when we talk about more complex things as servers and computers that are remotely connected and stuff are actually very accessible, and that I can manage and do them well in a simple way, especially with open source tools that are freely available for everyone, and that with a little bit of documentation that is available, for example, in the repository, you can easily replicate and do your own assignments or educate others on this type.
Just want to add, what you are seeing that I'm looking for is the documentation of these year master students, our MDEF students, that they are part of also the Fabacademy. So if you're going to see how the students interact during the session, so the best thing you can do is to see the documentation, and you will have like a, let's say, a real, let's say, impression of how the students like perceive the session. Okay, so let's continue. Yeah, sure. Yeah, okay. So let's move to the next two machines that we developed. The first one is the SPML that, let's say, originally it was, we call it like 6-pack machine because it has the size of the 6-pack here. But then we changed the name.
We have more official name that is a simple personal mobile lab. So you can call it as you want.
Yeah, what was the idea? So the idea was, as you know, so we tell you all of the strategies that we try to follow with the materials that the students had at home and are more available. But things like this, there's some digital fabrication processes that are hard to test it and learn it if you don't have like a machine. So the idea was to develop like a simple machine, a learning machine more than a fabricating machine, and we have to be clear in that. So the idea is, well, it's a 3-axis machine that can be basically designed for any purpose. And maybe Edu can explain how it came up this idea.
So the idea is not actually challenge like big manufacturers, because everybody knows that you have really expensive machines, medium cost machines, and cheap low cost machines that now are really affordable and actually are moving this digital fabrication world. The other point was to try to develop kind of a toolkit for the students that was able to be easy to hack, easy to build, and especially easy to understand all the process that is involved in the building of a machine. So actually, we also we were really confined, and we have what we had at home stored before the confinement. So actually, it's this, I'm like an old guy, and I store a lot of motors and these kind of things. So I have like DVD writers that they have really small motors and these kind of things. Actually, this is one small version that I developed at home just for fun. It's cookie engraver. And I say, okay, this actually is an Arduino, it's a basic thing with few motors and simple concept of mechatronics. And actually how we can distribute this in a way that the students learn and can actually do all the process and modify it from themselves. Actually, right now we have one student just in front of us has hacked the machine and interpreted in his own way to make a different machine. Yeah, we can see him working with a lot of cables. So we came up with the idea, okay, let's try to make a accessible machine, easy to build, as low cost as possible. Low cost was big concern because as an institution, like we cannot pay like €1,000 machine for each student. So having accessible of the cost was a big deal. And going after market and looking up for retailers and simplifying the design to the minimum amount of elements, we went to this project. Like that finally, just actually 1 week ago, we just finally got all the components because the delays of the confinement. We have tried like hacking different motors and everything. And this machine, we have fabricated the PCBs here in the lab with another milling machine. We ordered because we need to actually produce like 30 or 40 boards for each student that will solder at home, simplifying the components also on the PCBs. So it's actually they understand all the process. And we develop, or we try to develop 2 different versions up to now. That is like the 3D printed one. What happened when you only can access a 3D printer, a standard size 3D printer, like 200, 200, 200. So actually we find out, okay, let's say you order the components, like the motors, but you cannot fabricate the frame. Okay, you can go with a full 3D printed version, simplified enough. And the previous one was actually the orange, was the laser cutted version, where all the components are laser cutted. Our idea in the future may be to develop a CNC one, but that will say it's not that feasible for a student and implies more knowledge. So we will try to keep it to laser cut and 3D print for the moment. So the idea for this machine was to develop a multi-tool machine. That's why we also developed our own custom board that is Wi-Fi compatible. That means you can, at a point, control it also remotely from your own home.
Do you want to go to the repository? You want to explain the different like?
Okay, let's go to the
I think
repository.
so. We can explain a little bit the idea of the Arduino. I think it's a very nice concept because, well, the ones that you are a little bit all in the Fab Lab world, let's say, Arduino as it is, it was not our invention. It was first version of an, let's say, Fab Lab version of Arduino, and it was developed
By
first version
Luciano.
here by Luciano when I was doing Fabacademy. And what we did this year, it was basically redesign and use like a better processor with Bluetooth and Wi-Fi and well, everything that you can imagine now.
We upgraded the Arduino to the new times and new microcontrollers.
Yeah. So the idea was again, so can we have an Arduino version, or let's say a board that allows us or the students to learn almost everything related to electronics and favorable, let's say. So this is why we gave that one. And together with that one, there's the Arduino CNC Shield that maybe you can explain a little bit more also.
So basically the Arduino was presented as a, let's say, a favorable alternative of Arduino and kinds of compatible boards. That our main point of developing this one was to have the Wi-Fi and Bluetooth compatibility. So actually the students were able to connect between each other through internet. So actually helps a lot in development of the tools, and actually the multi-networking assignment was done all with the Arduinos that each student has fabricated at the start of the academy. Actually, Diane is showing one right now. So the Arduino CNC Shield, let's say, is a vitamin for the Arduino to allow to control like external motors, hardware, sensors, etc. So we went to different steps of the Arduino, trying to simplify the design as much as possible. So the latest one is breadboard compatible. The initial ones were not. So we tried to simplify and still use the less amount of components in order to make it usable. And we have the pinouts and how to use it, etc. So the documentation is still ongoing. So maybe you find something. In that case, you can make a pull request and fix it. So the CNC Shield is basically our own version of ramps, or like the controller of a 3D printer or a laser cutter that is quite compatible. We call CNC Shield because it was the main purpose for us in this case, and is the main brain of the SPML machine. So it's a daisy chain of things that happen Arduino when the CNC Shield we use for the multi-networking, and we found out, okay, we can even use for a machine. So SPML, and also the Kraken, that is the CNC by the sea. So you see, everything is favorable. Just because of amount of boards we need to manufacture, we send it to manufacture. You cannot spend like 1 month just milling on the machines. And the good point is has his own like firmware and software to control it. So it self-published a website from the main board that allows you to load the G codes and have live connections onto it. That could also be done via open port on your modem remotely.
Yeah, let me go.
So, yep.
Do you want me to run?
Okay, let's run the video. So, up to now, this is actually 3 days ago. We finally knew with a small mini motor, a piece of foam. It's not a professional machine. It's not for like high accuracy at all, but it's enough for learning how to actually build your machines and make you conscious that machines could be made, but everybody included, you can design your own tools. Actually, Armand that is here is designing trying to design a 5-axis machine, the same as we try to design this machine. Just next to me, I have the orange one that just is finished today. That is actually a bioplastic printer with a syringe and a small air pump to actually make it portable. And maybe
one together to the other one.
Okay, this is too much.
Oh, your babies.
So different versions, different styles. And the idea actually we measured today and we think that we can run it on batteries to make it even more portable. Okay.
Okay, so yeah, here you will find like the repos and basically, well, all the web pages that I was like opening while Edu was talking. And also you will find like photos and videos about the process and us going crazy with any small step that we was doing with the machine. So yeah, feel free if you want to contribute in the repo and also taking pictures of your process, the building one, or I don't know, replicating or I don't know, bring it to the next level. So please talk to us. And then the other tool we did, and is the ones that we wanted to challenge you to do today, is the CNC by the sea. So we put like a nice phrase here, so how we can bring the beach in the lab. But the idea was, again, so for the CNC, we couldn't like have access to the real CNC, let's say. So we decided to
how to explain the concepts
exactly.
of CNC
without
actually going to the lab. And we found out that we have the problem. Okay, yes, we can control a machine remotely. And actually with this package that we are showing you today, you can control 3D printers, CAD and CNCs, but you should not control a CNC with anyone supervising it. The same for a laser cutter. So, okay, we say, okay, we are in Barcelona, the beach, everybody's missing from home. Okay, let's put sun on the top of the machine. And that's where comes like CNC by the sea, because it's a machine that is for drawing on sun.
Yeah, so maybe Oscar can explain a little bit more in terms of, let's say, the group project that we was envisioned. Sorry? We are going fast? Okay, we can go in there. Okay, so if someone have like any questions about what we are talking, or you want like, I don't know, go more in detail of anything, just tell us. So I think so while the people is trying to operate the machine, we can talk on top, let's say. So we wanted to, let's say, talk less and do more. But well, anyway, so the idea, apart of having like this experience, again, apart of having the experience of generate the code, send it to the machine and have like this, it was also, again, how can we, for example, do something together? Can we create like drawings based on the incorporation of every, or adding like drawings on top of the other one? So it was part of the narrative of the exercise. It was not just like lines. It was like, I line something and then maybe another student can add on this drawing. And we can create like, let's say, final art piece, if we're talking about sun, maybe with the collaboration of everybody. So we are always trying to incorporate like these values of working all together to create more value to the experience. And we put here the links to the repo. If someone wants to replicate the experience, we can talk now a little bit more in detail on how it's created. And then you will see two more links, one to the JSON that basically is the one that allows us to load the G code. And then two webcams that are connected in the stream to see what's happening there. I will try to open and see. Let me see if everybody see that thing.
No, no estoy compartiendo.
Wait. Okay, now yes, isn't it? So you can put the, yeah, okay. So there are two cameras, yeah, and Neil there. Yeah, so.
He's resting on the beach.
Exactly. So if you want a challenge, you can try to, let's say, coach Neil, let's say, or make them fall, or
Okay. Oh, let's first explain how it was built.
yeah, and always go directly to the panel. Okay, so I'm opening the repo. Yeah. Oscar, do you want to explain a little bit what's happening behind everything?
Yeah, of course. Maybe you can make this image larger a little bit. We can see it in here. Okay. Well, so imagine that you're now in the context of the students already having played with the multi-networking workshop. They have been receiving a lot of boring talks about what the internet is, how to, what is a network, and this type of things. And then you can introduce this new concept, right? Like how to control a machine remotely and do it yourself with the same tools that you were using before, like a Raspberry Pi and an open source or an open set of electronics that can be used as a ramps or something like that for controlling a machine. So imagine that we have a lot of students. They are some students that are quite lonely at home in the lockdown. Some of them are not so lonely and they want to control a machine. And what we did is we put a Raspberry Pi in the lab with a public IP address and installed an open source CNC controller called the CNC.js. It's basically something very similar to Counterface, but that can be accessed on the browser, as well as, for example, Chili Pepper. It's another version that can control hardware from the browser as well. And you can install it as a standalone script in the Raspberry Pi and set it up so that users can interact with it and log in remotely. The idea was to have this application running with a couple of camera streams that are connected to the webcams and looking at the machine, and then of course the Raspberry Pi control to the electronics of the machine itself. How to connect the Raspberry Pi to the world with all these applications? Well, we used yet another open source project called NGMX, and more specifically a reverse proxy server. And this is probably too technical, so I'm not going into that detail, but if you want to replicate it, all the instructions are in the repository. And we really encourage you to, if you want to try it and something doesn't work, to make an issue or try to improve it so that so that more people can benefit from it. But the idea at the end is that you just simply have a Raspberry Pi with two webcams and an application running on it and a USB cable to the normal Arduino controller, the normal RAMS controller for the machine, and that is accessible via normal to the internet, and users can connect with it. That's why you have these weird IP addresses in some of the endpoints, because we didn't buy a domain that was very beautiful. We used some freely available ones like the cncbydescene.opti.org. But at the end of the day, it also helps the purpose to understand that behind every domain there's an IP address. Okay? So that's pretty much it. Then the students, if you go to the interface, if you want Edu, what they see is something like this. And basically, it offers an interface to control the machine as we are used to. You can upload gcode, you can open and close the serial port, and even see the webcam feed on the left-hand side. This interface is highly configurable with JSON file format, very simple, that is also available for this machine to simply import it and load it so that everything works from the get-go. And it also supports multi-users, but of course, only one user can send something at the same time to the machine, because the machine cannot be interpreting various files of G code at the same time. And as you can see here on the different streams that Edu is putting, you have a top stream that you can see what you're drawing, and then a side stream in which you are able to see the depth of the tool and see if you're actually touching the sand or if there's any problem, or just even just seeing it in the background enjoying what you're doing. And I think, well, I don't want to stand myself much more. If you have any questions or you think that there is anything that can be improved, we really welcome you to post issues or comments in the repository or here in the chat, and even interrupt us while we're talking. And I let Edu maybe explain a little bit more about the machine itself or interact with it.
Yeah, maybe Edu, you can go a little bit deep with the electronics that move everything.
Okay, so actually the machine, unluckily, was not documented. The only thing that is documented because we did on spare time, but it's not a special machine at all. That's also one of the main reasons not to document it, because it's based on the open build system that is like B square aluminum profiles, and we try to use the most standard things on the market. For example, we use this Arduino Mega with a RAMs, that is a really standard board for 3D printers. And we basically enable everything in the firmware, just in case. So actually the machine was built for the students to be able to hack it and not be afraid to modify it and change everything. And if they mess up, the only thing we have is limited the speeds and limited accelerations. So if you crash slowly. So let's say you have a standard machine, 3D printer, or like that has a standard more or less G-code interpreter. You connect the Raspberry Pi that Oscar was talking about, and based on that, it works actually as a controller and as normal machine. The thing is, you are not in the spot of the machine. Actually, I think it's the second time I use the machine on place. I always use remotely. And one of the best things of actually having this machine, and we had it open for 1 month running completely alone in the lab. Between all the stuff, we were checking every day, okay, everything is going fine, nothing is on fire, you never know. So we found out that we found randomly connected at 2 a.m. at night, and someone was drawing, just maybe because he was bored. And the best thing is we don't know who was drawing, because it has like hidden IPs to connect.
Let's say, I would say that all of you should test it, because we find every morning we were checking the cameras, all the team, seeing what was the secret message, and now I will share some of the images that the people were doing, and some of them, taking consideration that we are in YouTube, maybe they are not appropriated, but this is, students' work, so I will not.
Because the prize is students' work, not our work.
Yeah. So these are images that we was taking during the process. So we was entering to the cameras, and I was like taking screenshots, and you can see some of the drawings of the students, some other ones a little bit more, let's say, clear. Let's say another one's like more classics, as a Hello World. There was some of them that was, I don't know, send us messages. And I have to say that also the students find it like the process so interesting that roommates was sending like drawings. Roommates of students was also playing with the machine. So we create like a nice interaction ecosystem, let's say, between students, people that was not students that likes to participate in the project, and us. So
and also some students were leaving the drawing because we have a system to kind of erase it. So we just move a servo and put a piece of foam to make it flat. So actually some students, they didn't want to clean the drawing, and they were drawing on top of it. So actually they were designing on top of other people's drawing. And that was quite interesting, actually.
Okay, so I don't know what I'm sharing right now. I'm a little bit lost.
Let's jump onto the machine.
Okay.
Well, I will share with you the links of the webcam, so actually you can. We have 2 video streamings. The Pi is managing 2 video streams. quite comfortably with just a little fan so it doesn't overheat. We have one view from the top and one view from the side. The side is important because it's where you make the zero on the side of the machine, and in order to draw more accurately and know the amount of depth you take on drawing is important. As you see, it's not technological at all. It's just a flat screwdriver attached with some zip ties.
Maybe I can show to the camera closely.
It's actually in the second link, the 8081 action string, the servo with a piece of foam attached with tape, zip ties, and a screwdriver. High technology digital fabrication.
Exactly.
And here I'm sharing with you right now the interface that you can all access to it. Oh, sorry, yeah. Oscar sent you the good links with the proper naming. So when you try to log in, you will see.
Do you want to share your screen?
No, share yours. I go to your computer. So actually, you will see that it's a top view, but you can also have like three-dimensional view of the workspace because this JavaScript is designed for milling, actually not only to have remote control, but also local control. And we just repurpose it for our needs. We have the connections, like connect to the machine. In this case, the Pi is connected, in this case, to the USB 0. You have the console of the things that are happening on the machine. So you actually get live feedback, not only via the cameras, but also on what's happening in the codes. View the top view as a shortcut.
You should put manually if you want to see it here. So click here and edit, and then you should connect to the IP camera, and you should copy and paste it.
Yes. And the standard like menu for controlling machines manually. And basically, you have to upload G-code. So as an interface, we like it a lot because it's not transparent. Actually, it shows you a lot of things, but it's not overwhelming for the students. That's something that happens a lot, that someone that is new to technology, this kind of technology, just gets in front of a super complex interface like Match 3 or Match 2, and just gets, oh my God, I'm not touching anything because everything is going to explode. So also the colors, like the kind of interface, that's why one of the things we take this way. I don't know if someone has already went and gone into the machine. Actually, can we put the cameras? Or the, like,
I think Edu, probably they need. Probably they need as well to know how to load the JSON for the configuration.
Yes.
And the password, and I think that you saw them, but maybe we can put it in the chat.
Well, the password is here in the documentation. Okay, I will put it on the chat also. Okay.
Yeah, we have user and password, so not too many random people from the world can log in easily. So take this amazing opportunity to have the password and connect and play with the machine.
Now it's in YouTube.
Today.
So be careful. Look what you say.
Estás convirtiendo la presentación.
Wait. Send file.
So the file that Santi is sending you right now is a small configuration file. So when you go into the interface, the things are not in place and have different order. So it's just a small configuration file that is a JSON file that kind of makes you have the same interface for everybody without having to go into the deep setup of the interface.
Sorry, I'm closing tabs. Giuseppe will send. Actually, Giuseppe didn't say anything. Giuseppe is the guy with this cover, you know. It's also it's one of the guys that are behind also this.
Actually, the blue comes from his hair.
Exactly. You send?
Yeah. So the file that you have right now in the chat, you go to settings. Come on. Let's see if we remember.
No.
workspace.
Workspace. So you import the JSON file
And then
that right now Santi has already uploaded, and that will change how the interface looks for you.
Let me do what I will do. Okay.
Restore the defaults and just upload a new one.
So I need to find the chat. The chat. I wanna download the file and put it here while they're doing. Is the okay, there's too many things. Okay, it was that one. Okay. Okay. Import. Download. Okay, done. Perfect. So we can continue.
Stop moving that fast.
Oh, someone already like.
Whoa, someone is really fast. So for the ones that doesn't feel that comfortable, you have to go to port, select def TTY USB 0, and the baud rate is 200. No, 225.000 and connect. In that moment, you will have the interface connected. And before anybody launches the file, we always recommend to move the Z up so you don't crash on the sand, and do a G28. That is
what I will do is I will put the other screen here.
Yeah, put both screens.
Okay, so now I think so we can see everything. You will know that you have access because basically these buttons, the buttons that the X and Y buttons to move the machine, you can touch it basically. So if we move, well, it's going 1 millimeter. Let me go like a little bit more. Okay. Okay, so the Y, it's very difficult to explain this, but the Y, let's say, well, I don't know how to explain which is the Y and the X with your point of view. But the size, this is something maybe interesting for you. The size of the bed is 700 by 700, but please don't do a drawing of 700 by 700 because we will stay like drawing forever. So try to do small drawings. And then how can you generate the G-code? Here, wherever you feel a little bit more comfortable. So I think so the fast way, at least for me, is using Inkscape. Inkscape by default, at least the last version of Inkscape, it have like a tool to generate like G-codes from path, and by default you don't have to do anything else. Then after you generate the G-code, you have to basically change some parameters to adjust the velocity and the zip.
Yeah, so depends on the tool you use for producing the G-code, like a G-code parser, for example. You can also use RhinoCam or Aspire, like that. Anything that outputs standard G-code will work. Also, Inkscape, in case of Inkscape, as is mainly for like 2D drawing, you need to modify a little bit with a notepad editor like Atom or Sublime or Brackets or whatever, just to be sure that the values are okay. So just send a G28, for example.
So if you go here to the console, you can send like directly comments. So if I send G28.
Yep, you will just go home. And right now, the machine has made the go to origin in X and Y, and now it's doing the automatically Ooh,
Well,
server stop working. Oh, direct things. Live, completely.
maybe so many people trying to access.
Ah, you got kicked out.
Yeah.
That's weird.
Maybe it's in YouTube, so there's so many people that knows a lot doing.
Yeah.
But we don't
But
know.
we tested the machine with around 30 students connected in live, and actually, when you go inside, you can take the control over other people's job. That's also like something funny that we were playing to see who was in control of the machine, and maybe right now we are exceeding the skills and the capacity of processing of the Raspberry Pi.
I'm trying to
Santi.
access.
Can access?
Is someone? Do you have access? Someone else have access or not? If
Let's
it's not,
see.
we can.
I also got kicked out. Let's see. Bad gateway. Let's see what happened.
Well,
Guys, yeah, I connected remotely via SSH and it was very slow. I think that's probably too many people connected.
Okay,
for the
so-
Raspberry Pi
Even Oscar is doing like remote
Monitoring.
maintenance of the machine. That is
okay, I think
even
so.
better than the local people.
I think so. While it's restarting and we try to access again, I can explain the process to generate the G-code in Inkscape if someone doesn't know how to do it. Yeah, let me share the screen again. I can. Okay. Okay, so this is Inkscape. So the first thing that I suggest you to do is to basically go to document properties and try to make it like a little bit bigger. Oh, this is always one thing that happens. Wait, let's see if now anything wants to work. And well, anyway, there's a way to rescale your canvas, and you can do it by 700 by 700. Okay. Let me go again. Try it. Okay. Document properties. Okay, now it's working, and I will share the screen. Okay, let me share again screen. Okay, so you are not seeing what I'm doing because I'm just sharing the screen, not the pop-up screen. So, okay. Oops.
It's back to life now.
We are back to life. Okay. Okay, so I'm here. No, I cannot. Do you have Inkscape? Can you share your screen and I can talk on top if you don't want? Because the problem is that I cannot share the entire screen with the. You have to share the screen.
So someone already sent a file. The fastest guy in the west from Barcelona.
That was me.
So the speeds we recommend, so don't make it too slow, is like 5,000 millimeters per minute. So we go fast. We can go quite fast. And to draw on the sand right now is more or less a Z0 level. So you can go Z -1, -2 in general. So you with -2 you will touch the thing because the ones that you can see on the webcams, Gustavo I think is drawing right now in the air. So let's say how to cancel it or how I can take control over Gustavo is I can close and open the connection and I just stop his process. So I will make G1 Z 20 go up fast, G1 and G28, so it makes home again and we can have a fresh start.
It's weird, but it's what it is. Okay. No, yeah, yeah. I will try to explain it like this, even if it's not in real world. At least the people will get it.
Share the screen, Santi.
I know, but I just can share one window, not the entire screen. So it's
Linux problems.
well, okay. So everybody's seeing screen. So imagine that I wanna draw something. This is 700 by 700, the canvas. So this is the basically all the area. I will try to draw like something that it's not, let's say, super big. So if I have my drawing in lines, let's say, there's an option here in the extensions that it's, and it's, yeah, this is sharing, okay. So Gcode tools, and there's one here that is like path to Gcode, okay. And by default, you don't have to touch anything because we are not gonna, actually we are drawing with a screwdriver, so there's no possible tool to define that emulates that. But what you have to make sure is that that Z safe, so it means that when the tool like moves from one side to the other one, it's like enough, don't touch to anything. So 20
move in the air like 10 Z 10 or higher.
Yeah, and then choose where you want to store the file.
No sale, no se está viendo.
Yeah, yeah, I have this. Okay, I have to share any small windows. I have to share.
You can share complete screen.
No, I cannot.
No.
No, I mean now
Okay.
it's not the time to talk about this. I cannot do it now. Anyway, so okay, what I was talking. So these are the when you choose like path to go to Gcode, these are the pop-up menu, and by default you don't have to touch anything except this one here. Okay, that is the Z higher millimeters that it will move up when it's moving from one side to the other one, and where do you want to storage the file? Okay, and then if you want to change the name of the file, it's okay. So I will put like test fab x live
ng.
It's okay. So one thing that maybe will happens to you is you have to select which path you want to convert. And if you apply it now, it will pop up something that you are not showing, that it will say, I cannot find the method tab. This is because you have to go to this tab, path to Gcode, and then click in apply. And if everything goes well, another pop-up message that I will show you now. So maybe no. No. Is this one? No. Will appear telling you that everything goes okay. And actually, yeah. Good. You will see something like this. Okay. So these are actually the different like speeds, well, the properties of the Gcode that it generates, and these are basically the path. Okay. So this is how Inkscape like visualize code that it generates. And then if we go to the folder and we open, now you will not see it, but I will show it to you in a moment. Okay, give me a second again. Share. Okay, now everybody shares. So this is the gcode file when we open. And actually, here we can see the zip. Let's go okay. And yeah.
Yes. So first, the file, what it will do is not doing any home. So wherever the machine is, it will start drawing. So it's important to make a home of the machine just before launching anything. You see G21 is working millimeters, and we have G0 Z20 that is moved high and go to the next position that is X72, Y69. So in the moment start drawing, that is the G01, you can see that the Z is kind of so-so, and depends on the scale you use and the version, this value might change. So to want to be sure that you control the amount of depth you go with the screwdriver into the sand, let's change it. For that, let's use the fast commands of these text editors and like find and replace. So in case of brackets in Linux is Control H.
Control H, yeah.
If in Atom in Windows is Control F, so depends on the.
Yeah.
So in this case, we will copy the. It was Z minus 0,125, and we will replace by Z minus 2
It was
or
minus 2, I think so. Well, let's test minus 2. Okay.
find replace all. Resolve. Okay. And we will do the same for the speeds. The speeds right now are really slow. So F is the value for the speed. Right now it's 100. If we do it at 100, we will finish tomorrow night this drawing. So let's change it to 5,000. So we will replace all the F something by F 5,000 or 3,000. And depends on your style.
Because there's two F. So make sure that we replace all of them. And then we can remove this part also, no?
Yeah. We don't know why, but Santi's Inkscape version makes the double drawing. So it sends the same G-code twice. So we will erase it. Depends on the software you use, will not produce this kind of things.
Maybe someone knows from the audience.
Yeah. Someone from the audience knows this bug. Please tell us.
Yeah. You are all so quiet. Huh?
Yeah. Interaction.
Okay, so while I'm done with this, I will try to
save the file.
Share again. Okay. Now I will go here. Everybody's seeing this thing now.
CNC by the C.
Yep, sorry. Yeah, it's interesting. Whoops. Someone sent something? Who sent the file? Okay, should I move it?
Always before going home, make the Z in the air. Move it quite high.
Okay, so now I move the Z up. Okay, you can see there. In this, oh, I cannot do this thing. So here, actually, whoa,
oh, a face.
Someone funny. Let's see if someone sent it.
No. Oh, someone has done a G28. It's coming. Takes a while.
Okay. Oh, did you modify the velocity?
No, this is homing.
It's
going over.
It's going to see.
Yeah. Who is controlling the machine that slow? We want to remind you 5,000 feet, not 5.
Yeah. That's 5,000 millimeters a minute, right? That was
Yep.
it.
It was you again?
Yep. Let's see. Yeah, 5,000 millimeters a minute.
Look, I open, close, so it's just stopped you. So for example, first thing I will do is G1, Z20, F5000. So it goes quite fast. Actually, can I scroll down a little bit this? So you can see, yeah, the camera. So for example, if we send X, I know we are right now 300, so 400, Y 400, F 5000. So we can send a G28, so it goes home, and Santi can send the file.
And I don't know if you noticed, but all of this workshop we did it just to be able to send our file.
Meanwhile, he's doing
No,
this.
please
Let's
let
upload the
us
G-code.
know to send this test file, and then you can send. Sorry.
Another thing, instead of sending files, could be we can play games. Actually,
Wait. Let's send just one file first.
let's send one file and let's play a game. So you can take other people's control. So Santi just upload the file, wait till it finish. You can see echo busy processing. The machine is working, doing the home.
Oh, okay.
Okay, so it says okay and run. So you can see the machine is drawing the small spiral.
But we should going down a little bit more.
Okay, so let's play a game. Who wants to play a game? Someone? So we have Neil here in the middle of the beach. So who wants just to just fall down like the fans?
Someone send again another file.
And let's put a little hammock on the back. So who wants to make Neil sit on the hammock that just has on the back, on his back? So you need to go and touch Neil gently by moving the machine manually.
But with arrows or with G-code?
That's up to them. Like you can send manually the G codes by typing. G1 is move and X are the positions, or you can do it with the arrows. Just share the cameras so they can see the both cameras. Can you show both cameras at the same time?
Not me, but maybe you can share your screen.
Okay, I will share my screen. They change everything. Okay.
No. Do you know what I'm thinking? It's a matter of rights.
Where is the cameras? I also need to. I will stop sharing for a second. Chat, cameras.
I don't think so. You can. They touch it, no?
Yeah, they touch. So what I will do is I will be changing between both cameras. So somebody just hit me. Don't hit me. You need to make it lay on the hammock that just has behind it. This little hammock.
All right.
Ring the bells that still can ring. Forget your perfect offering. There's a crack in everything. That's how the lights come in. Well. Unknown command. The command, someone is trying to send a G-code. I think it's missing the command G1 at the beginning of the X and Y, and the machine doesn't recognize it. You need to move.
Maybe Edu, you should explain which one is the X and the Y.
Okay, yeah. So Y and X. So I will drop here Y. Let's put that one. Also, it's fun that they discover by themselves. Come on. It's a fail. And we have the extra option. For that, we will go on the side camera, string top, and I will show you on the second camera. For that, we can change here in the settings menu, the IP camera. Maybe with that will work, I don't know. Let's see, yeah. So first I will move up. G, in this case, I will move quite up. And I will get closer to in the X, yes, in the Y. Okay, X 200, Y 200 at 5,000. Actually, the machine doesn't know where she is right now, so let's make a G28 again. And I will show you, because one thing that happened along all the confinement is the students were drawing with the screwdriver, but nobody was here to make the sand flat again, and so they had a flat surface to draw on top. So that's why we enable a small servo with a piece of foam that enable them to move the foam down and kind of clean the sand. So when the homing finished, I was playing the two small commands that we use to deploy the cleaning brush. And this is the slowest machine on earth.
G-code. I can put that in the...
No, el de aquí, no es el de limpiar. Okay. Almost there, almost there.
Edu, quick question. How easy it is to flip either the camera or the orientation of the the top view, because right now it's inverted from the controller, so it's tricky to think.
The setting is not very complicated, as you can see.
Right now it's just let's say
Webcam.
a stick with zip ties on the side of the machine. We can try to change it. Meanwhile, you're trying to change, I'm going to explain you the G codes, the deploying the probe. So I'm going to move to a middle position. F5000. Let's move also in Z up. 80. So what we can do now is deploy a servo. How we deploy the servo? There is a command, M280. I will copy in the chat. P1. And right now the servo is in position 90 degrees. So we want to move it down, that is 0 degrees. So we just deploy the probe. And with that, we can manually move and clean the sand. Let's say we want to move it back to the position. The same, M280, that is move a servo. P1, that is the servo we want to move. And S is the angle. I want to retract it 90 degrees, so it's 90. I can also move a little bit more in, I don't know, 400. Yeah, Y300. And I can try to hit it with the servo. P1, S0. Uy, casi. G1, Y350. And retract it back. So 0. No, sorry, it was 290. I will copy this right now in the chat. So where is the chat right now? Chat. Servo commands to deploy M280 P1 S0. Servo commands to retract M280 P1 S90. So I'm gonna clearly stop making any commands, and I want you to actually do the real live testing, and we are gonna make that we are not here. So it's completely up to you guys how you control and how you do it. So if anyone has questions or anything, wants to ask anything, or needs help with how to draw a cheat code, Gustavo seems really concentrated.
I was looking at my G code, why it was slow before. It is sending the F5000. I don't know why it was that slow.
Can you copy your G code on the chat?
Yeah.
You sure that you're working in millimeters and not in inches?
Yeah. Oh, I see. The first few commands were slower, probably because the way that I generated the G code, but then when it starts drawing, it's 5,000. So I'm just going to change everything and then try sending again.
If we change the camera to the top, now the top camera has changed and has more or less the proper orientation. It's not especially straight, but Now the camera is aligned. Now the camera is aligned with the control that you have on the machine. So let's change the address of the camera so we can see the site. One, and you can control as a standard one.
Okay. What about this? Is someone else trying to operate the machine or not? We know like Gustavo's trying. Adrian, we want your drawing.
Another time. Because I'm doing a lot of things now.
Well, we
Sorry,
know
Santi.
No, we know that the process is not depurated enough, but it's part of the
Learning curve.
Learning curve and experience. Of course, better documentation will help.
I like the part of the using the Inkscape to generate the G codes, because when I start to create the G codes in the NTM class, in the NTM assignment, I have a lot of problems with the Inkscape to create the G codes, and finally I don't remember. I think I use Aspire to create the G code and send to the same platform, to the
Yeah.
Yeah, actually, if you use
PLC.
Aspire or RhinoCam, you can also just choose the standard decode termination, and you can also use it for this.
Yeah. Okay.
Actually, this machine is a little bit of Frankenstein. It's big as a plotter, control board of a 3D printer, and G codes of CNCs.
Yeah.
It's a mix.
Okay. Someone sent something else. I think so.
Someone is moving again, the machine.
Yeah, I'm sending the face drawing, but it's now, I guess it's just an air pass. Then I'm gonna lower it a little bit.
Okay, Philip points out that he's using Fusion 360 too, doing a G code. Ooh.
Yeah, again, here we was trying to make it as much accessible as possible, and let's say start drawing as fast as we can. So this is why we choose like tools as Inkscape. But Edu, for example, was using RhinoCam. I Rhino a Grasshopper for drawing the G code, so you can choose tool that you feel more comfortable. And actually,
Okay,
I don't
now
know.
we are drawing.
Oh, okay, in a spiral.
No, it's not a spiral.
Ah, no, it's the, okay.
It's circles. It's a small circle.
No, it's writing, isn't it? What? Can you refresh? Can you refresh your?
This thing is frozen.
Yeah. Can you refresh?
I guess it was the eye. Now it's the mouth, and then it stopped, or no? Yeah, it's
no. Refresh.
Yeah. It's supposed to be the face.
Here. What is the refresh button of this?
Here. Refresh everything.
With icon refresh, I will disconnect it, no? Okay, let him finish the drawing. Ah, it's the small face.
Yeah.
Huh.
Yeah.
Good.
So you are not. This is what is going on.
And this drawing comes thanks to
Gustavo.
Gustavo from
Brazil.
Live Control through internet. Let me refresh the workspace.
That's
So,
awesome.
Yeah. Okay. Yeah. That was the thing we just draw. Who's the next one?
I can try to send one.
Go on. Actually, we are here, but we are just in the table. I think I can move outside, so actually you believe me that we are not in the same room or connected through a mysterious cable.
No, and I think so. The nice exercise will be to leave the machine open or on.
Yeah.
For a while. Let's see, and let's see tomorrow what we find. Which message someone give us?
Philippe, do you want to give it a try?
I should modify my script. I'm a little bit too far to do that right now. Thanks for asking.
Okay. I will draw something classic, but someone has to do it.
Someone is drawing.
Again, refresh your.
No. It's
On top of the other one?
I don't know. I think it's Gustavo again because it's moving really slow.
No, it's not me.
Who is? I like these mysterious times. Let's go to the other camera. Is not touching the sand. I don't know if it's moving in the air or it's trying to draw. It's like 1 centimeter or half centimeter. We can see from the little shadow that shows on the. Yeah, now we are drawing. It's the same drawing.
Yeah, if someone press like twice.
Yeah.
Play. Okay.
And
Is it done? Is it done?
no, someone connected online. Okay, Santi wants to share your screen.
Oh, no, but someone else is drawing.
Ooh,
Dun, dun.
a heart.
Don't forget to do the 0, 0. And I will take out Neil.
You need to actually send the G28 command. Note G0X0. Yeah, exactly. Because when you connect to the machine, it just resets and forgets where the origin was. As we are using Marlin, that is a firmware for 3D printers, doesn't have the variable absolute and relative origins, G54, G55, or other CNCs that they remember the machines because they save the home on the EEPROM. The firmware that we are using doesn't save it. Actually, it would be nice that maybe we can change it to that.
So Edu, that's me again. I just sent the G28, and from that, can I just press play, or should I raise the Z? I'm using 5 minutes.
From that you can just press play.
Yeah. All right. Let's see.
Wait, this stream. little bit delay. There's so many people. I'm going to close this camera, and you will see it from here. So it's faster. Cute drawing.
Thank you. I'm in love. But it was the quickest thing I could find that was thick enough, because it's from the top camera is tricky to be able to see the drawing. So now this one, I guess we're going to be able to see it.
Oh, this is the side.
Maybe, what do you think?
Maybe we can see better with the, let me see the top. It's better. Now we just switch off the lights.
Yeah, now it's better.
So now it's better?
Yeah.
Quite.
Guys, I missed something. How do you clean the sand after when the drawing are done to get it flat?
For that, the students were making a zigzag pattern. I will do it in Rhino, but you can do it in Inkscape. So
You want me to send them?
they were making a zigzag pattern just like this. And they were testing the Z where the probe was, like the servo phone was testing.
We are not seeing your...
Sorry. And how I can share again?
No, the thing is that you have to share the window, not the...
So let's say this is the machine. So the students were making a pattern like this.
Okay.
And they were looking the values for the correct Z with the probe.
Okay.
When this drawing finish, I can do a small test with you.
Okay.
Where is the zoom? Share the screen. I will share the again. So this drawing is infinite. He's drawing again and again and again the same part.
No,
love is infinite, guys.
Did you send twice?
No, it has a lot of lines really close one to each other.
And here we have also the problem that the sensor...
It's a 4 minutes code.
Not a big deal.
Okay, while we are waiting for loading our drawings, what do you think? First impression. So, or let's say, did you develop strategies or tools with the same approach in your labs?
Yeah, we would love to hear what were the approach to this situation that we all have and we are managing actually right now.
No,
Nobody.
Yeah, maybe something. I will turn my video on.
Sorry, Philippe, I didn't hear you well.
I'm just turning my video on.
Okay.
Okay.
Yeah, it's not directly related to CNC, but more to a laser cutter. When you're working with remote students, got it well that you can give them some autonomy by giving them a small 3D printer, a small CNC. But what about the laser cutter? Do you have any advice on that? Should it be better to sell them from pieces? What should you do? Because we cannot sell each of them a laser cutter. There's no way to do that. It's way too expensive.
Yeah.
But what should you do?
Well, I think so. From my point of view, so we was thinking like we will put a laser and we will engrave in this machine because laser with lower power. But I think so. I think it's better if they stay with the concepts. I mean, if we stay with, if we can teach like the idea of subtracting manufacturing, and then the idea that there's 2D drawings on how to operate, what it means like, you know, the workflow, let's say, with the machine. I think so. I will not say that it's enough, but I think so. You can learn a lot and you can understand the possibilities that then you can do it in a laser cut. So I don't know if we have to replicate all the digital fabrication technologies that we have in the lab at home. I mean, because maybe it's too much. From my point of view, we have to, or at least in the first like step, if we stay with the general concept, let's say, and they understand rapid prototyping, subtractive manufacturing, additive manufacturing, how to operate with them, even if it's a CNC or if it's a vinyl cutter or it's a laser cutter. So the concepts are there, let's say, and this idea of transfer design to work with the machine. So these workflows, I think so. It gives like, let's say, a huge role to play, let's say, and we are not. I mean, these as we. From my point of view, these are learning tools, and I mean, this is, let's say, we are trying to have like an hybrid ecosystem, and we are offering the possibility to learn at home, but also taking in consideration that at some point they will have access to the lab. So we are not trying to replace one to the other one. So it's the way that at home you can learn some certain things, and in the lab another ones, and in another place. So because lasers are quite like dangerous.
The point of, for example, like just to answer directly to your question, like why not to use the lasers? Even low power lasers, like at some point there's a fire hazard, the same as CNC. That's why we went for SAN. And actually, we have the machine with a small router that will not be really dangerous to operate, but also they have the problem. Okay, you can CNC a piece of wood, but at some point the wood will finish, and someone needs to go to the lab to replace it, let's say, or a piece of foam. In case of the 6-pack, for example, we went that lasers can get you blind. Even like the super small, small lasers for engraving can get you blind, that they are not that safe. And also the cost is not that low compared to other tools. And the point for us was not actually it's a CNC, or it's a 3D printer, or it's a serine printer, or it's a drone sewing machine. It's about Santi was explaining, the process involved, and open up the black box of machines. So they understand what's really behind them, and there's something that can control and feel comfortable while using them.
Yeah, I got it. They know the principle, they know what's behind, and then they can. Your assumption is it will that epidemic, that problem will, that pandemic, sorry, will end up somewhere in time, and they can come back to the lab. I got it.
Exactly.
What I had in mind was, would it make sense to laser cut pieces for them and to send them to their home? And
we did. We was offering. I mean, we had a huge lockdown, let's say, where anybody could move, but there was a moment that the
staff could access partial access to the lab, and actually we set up all the computers connected to the machines to have remote control, and they just call us, hey, can you please put this end mill, or can you put this material? And we basically just supervised that the machines were operating safely and that nothing wrong was happening.
It's time consuming, but at the end it works.
Yeah, for me, and it's, let's say it's not a problem, but we also, I mean, we did it because it was an exception, exceptional like situation.
Exceptional times need exceptional measures.
Yeah, but in terms of learning like process, this idea that you send something to fabricate and then you basically receive it at home, it's not the experience that we would like to offer, let's say. So there's something else when students face the problems that means operate the machine and also like see it there. But of course, I mean, we tried everything, and yeah, some students they was using, some other ones they was waiting just for reopen the lab to come and do what they couldn't do it.
Yeah, we saw it clearly with especially molding and casting, that we did the class, like funny class about how to use DIY stuff to make molds. Like take a piece of Lego that you have and try to replicate it with chocolate and gelatin.
Jello molds.
And got excited about that, and they tried, and of course they failed because it's gelatin and it's not that moldable. When the lab opened, actually they feel much more comfortable with the process. At least they know like the workflows or the theoretical workflows, and they have experienced them, and they went to the machines much faster than the ones that didn't try.
Basically, instead of losing time, you gain time. Yeah.
Exactly.
I got it. Thank you.
Someone is drawing again.
Yeah,
what's that?
Slow, so
Is my screen frozen again, or I don't know. Server working. Loading. I think I stopped someone.
No, I stopped.
You stopped it.
I did it in purpose.
Okay. So, for example, Philip was asking how to clean the thing. So, for example, right now, we can see on the side camera, yeah, the probe is up.
G28?
No, don't say a G28, just move it higher.
I already moved it higher.
Yes. GZ60 or 70.
What? No, it's okay.
Okay.
Even more?
Deploy the probe. So to deploy the probe was the M270. This is actually, we don't want to focus on the G code, but we think that understanding what really happens behind everything helps for the students. 280 P1 S0. Okay, and now move slowly to the Z down. Slowly.
That's super slow.
Okay, and now that's the Z you have to put on your file. So you make the file with this Z level, and you just leave the probe at that position. So now move, for example, in Y, and you can start cleaning the little heart of Gustavo.
No.
You broke his heart.
Go, 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 go.
Bye bye. Bye bye by the sea, no?
Bye, 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 the sea. Yeah, exactly.
Well, this is.
At some point, after 3 weeks of working, we had the problem that we have almost not sand left over because they were cleaning it away from the sides.
I don't know if it would work, but a vibration table should be an option.
Yeah, that would be good. Yeah, that was actually that's an amazing idea.
Yeah, I had a question about this. How difficult it is to maintain this thing running?
Actually, has almost no maintenance except for when Oscar jumped in because there were too many connections. But I think we keep it working for 1 month and something with just one like reset of the pipe, like remote reset, not even like going inside the thing. So as long as you have for example, we have a fan cooling down the pipe so it doesn't overheat and this kind of thing. and the fuses of the building doesn't go down, it will go, let's say, standard equipment, more or less. Of course, it's
Nice.
not professional and bulletproof, but as far as tested, has worked good enough. What are you doing now?
Well, now it's funny.
That's why it's like CNC by the sea, because you find people like Santi, like they become a kid playing in the sand.
No, this is a Zen. This is a Zen.
It's a Zen
Dawn.
garden.
No,
Okay.
I'm not touching it. Well, just some of them. Bye. No, it's okay. Okay.
Think paintbrush drawing. Oh my God. What Santi's done has crashed the machine.
Wait.
Okay, move the proof up and just do a home.
P1 was S0.
S0, S90, M280, P1, S90. Move up the set.
No, I will to that one.
Yeah. Actually, that's Santi is doing what the students were doing. That is actually hard testing the machine and crashing it everywhere. Surprisingly, the machine is still alive. Something.
It's perfect.
Okay.
Okay.
No, puedes darle más servo. Don't move. We can do it. So for now, for example, the servo is broken, let's say, but it's not broken, it's a different angle. So what we can do is send the same command, but P1 is 120. So we change the servo angle. So actually, that's something that the students got to understand it and manage that by themselves. And we were quite happy with that, because at the start we sent a cleaning script. So they have it automatized, but at some point the script wasn't working because the sand was lower than the beginning. So actually they start modifying their own scripts and managing on their own. It was a quite collaborative month in that way. With that and with the multi-networking, they had a lot of fun. Well, as fun as you can have in a confinement. But
No, but they appreciate it a lot. They appreciate the effort we did, even if sometimes it was not like a perfect session. And because they didn't expect to be able to do it. So
we also didn't expect. We become quite creative, or we try to. Well, we are almost at the end of the session. This session.
yeah, I think so. We can wrap up a little bit. So I don't know.
To share the presentation?
We already shared the presentation. I don't know if everybody have access. It's important because there's all the, let's say, links to the repos.
Let me show it again.
I think so. We open, no? So there's no necessity to give the rights to people.
No, it's reading rights.
Okay.
I'm sorry.
Yeah. So yeah, if nobody wants
we
to
are-
add anything.
Do we have some people in chat talking? Where's the chat? The chat disappeared. Okay, can you read the chat, Santi?
Yeah. They say thank you.
Ah, thank you. Okay. It was a great pleasure to have you here and show your interest in like the tools we try to develop, to try to make these new methodologies, educational systems, and machine and digital fabrication, try to be more accessible. We tried our best, and with the tools and time we had, and we hope you enjoyed. And actually, we can leave the machine connected, no? For
Yeah,
1 or 2 days.
I will do this exercise, this test. Let's see.
Let's see what happens.
Yeah. And Gustavo, what is this easel? Did you try it?
Easel.
Yeah.
Easel is a super nice tool. It's super easy, actually, as the name states. But I think it's closed license, no? Or you can use for free, but that's like premium software that you can use for free, not with all the compatibilities, but it's super nice for teaching kids. Well, not kids, like if you don't want to worry too much.
Yeah, basically it's the software inventables created to use their machines, but it's free to use. The only thing you need is to create an account, and they have a pretty nice interface where you can draw and generate the G-code at the same place. So it's pretty intuitive and easy to use.
Okay.
Thank you, Gustavo.
Take notes. I will put. I will include it in the presentation.
Thank you so much, Santi and Eduardo, for this amazing presentation.